Hi everyone, Engineer New here. Well, this is our 11th video on the C programming series tutorial. So on the last video we talked about structs and how we could define our own variable types. So I guess it's time already for us to talk about how we can obtain more dynamic and celerity in our work by avoiding duplicating code and making our code more increase the abstraction of our code and make it more easy to understand and maintainable. So I will give you some examples so you will see what I'm getting at here. So let's start by tutorial 11 and then let me see where did we stop last lecture. So it was example 16 and then this will be example 17. Let me increase the font size here. Okay, so where is it? Text spacing. Initial terminal size. Is this it? No. Here we got. Okay, now I think you can see everything better. So let's start by example 17.c and start by writing our usual boilerplate code, which I believe at this point you have pretty much memorized, I guess, most of it, or at least, or most probably everything. So here is our main function, which returns 0 if everything runs smoothly. A main function with our arguments. So for now we stick to the void. Let me check and adjust this over here. Okay. So if you remember from last lecture, we talked about defining our own data types with structs. So again, I will define a data type using type definition because, you know, I'm lazy. So type def struct, we call it points, and then we have float x, float y, and then just call it point. And then we created points p1, p2, and let's say p1.x equals 0, p1.y equals 1. So yeah, p2.x equals, so we have a point here and the points. Okay, so I want to measure the distance. Well, let's place this at the origin so we get the square root of 2 for the distance between 2 points. That's what I'm getting at here. You will see, which you'll see in a minute. Okay, p2.y equals 1. Okay, so we have a straight line and I want to measure the distance between the 2 points on a Cartesian plane. Okay, so to do that we need to use, I believe, math, a library, math.h, and then we print f the distance between the 2 points will be a float, of course, and then square root of okay, so we have p2 dot y times p2 dot y minus p1 dot y versus p1 dot y. In case you have any doubts on what I'm doing here, you can take up you know, the formula for this. So yeah, distance between 2 points. Okay, so it's a square root of the difference between the 2 points. So back at here we have, and then oh yeah, p2 dot x times p2 dot x minus p1 dot x times p1 dot x, which will be the squared, and then yeah, and we close this brackets over here. So if I try to compile this program, let me use this flag over here. And define reference to sqrt square root. That's because we need to link to the math library. Okay, I'm not really sure how to do that by heart. How to link math library in C. Okay, and then you have to pass some arguments. Okay, so we just have to pass this lm, and there we go. So let's check, and the distance between the 2 points is 0, 0, 0. No, that's not correct. And check it again. So 0, 0, so 1 minus 0, it's squared. Oops, I made a mistake over here. So this is minus. Okay, so we have to square this using pow, which stands for power, and here also power, and then okay, so it's power to the 2. Okay, I believe now it's working. Distance. Okay, we missed some brackets here, parentheses here and here and here. Of course we need another one, and now I think we're good to go. And then oh, it's 0. Okay, it's 1. P2 here it's 1, so it's 1 minus 0 squared, which is 1. Okay, I see what's the matter is. Here actually it's plus. Okay. Yeah, so we finally got a square root of 2, which is approximately 1.4 414. Okay. So right, so this is the sort of cumbersome and not so smart way, the high effort way to do this. So there's another way to do it, which is using functions. So we will write a function much like main, but the difference is that it can return a value or not. So that's the difference between a void and a non-void function. Okay, so basically a void function is a function that doesn't return a value, in case we have here main, which is an int. This indicates that main returns an integer value, which is 0, but we can have functions that doesn't return any, that don't return any value at all. So so let's make some examples here using pointers as well, and passing by reference and passing by value, which is another topic. So first things first, well, let's write a function that returns a float value, which computes the distance between 2 points. Okay, so floats compute distance. So it would take a points p1 and the points p2, okay, as arguments. Okay, these are the arguments which are passed by value. As you can see, they're not pointers, they are variables, and they will return something over here. Okay, so what we're gonna do, this could be any points p1, p2, and then we're simply gonna return this over here. Return square root of power to 2 of this difference plus the square, and then we take the whole square root thing. Okay, and now here we simply call let's call this simply distance for the sake of simplicity. Distance, and then we call distance and p1, p2, and this is much more simple if we want to compute this for, I don't know, lot of points. Okay, so we have our function over here, distance, and right, let's compile and see if it works. And of course I forgot to add some semicolon here, and let's see what we got. Yeah, the same thing. So what I've done here is that I automated sort of way, add a level of abstraction for the programmer as well as any other developers, maintainers of the code. So as you can see, when you call distance and you in the second moment you will write a unit test to check if this function is working properly and check edge cases and so forth. So you don't have to worry anymore about its implementation. Just call it distance and provide the correct arguments, and voila, you got what you wanted. Okay, so this is an example of a function which returns a value. So we can have besides that what is so-called void functions. Okay, just keep in mind that the value, the type of variable that you're returning here must match the return type. Okay, so if I just put the integer here and this is returning a float, it will have to cast and from type to another, and then you can arrive to all sorts of problems. Okay, so yeah, let's write a function that takes 2 points, but instead of passing by value, we will pass it by reference. So we will deal with its pointers. So let's take, I don't know, normalize. Okay, so normalization in Cartesian coordinates and points means that you would take the coordinates of that point, and then you will divide it by its norm or distance. Okay. Yeah, that will in this case apply to a vector, not to a point. So let's think of another example. Let's take simply the absolute value. Okay, so if there are any negative numbers, we just swap them to positive numbers, and we'll pass a point P by reference. Okay, so by its pointer, and then we check coordinate by coordinate. So if P x is less than 0, we'll P dot x equals minus P dot x. Okay, and if P y is less than 0, we'll simply swap its signal. Okay, so it's minus P dot y. So remember from last class, we talked about when we're dealing with the struct which has a pointer, we use this symbol here instead of dot, because you know it's an arrow and you're dealing with pointer, so it's pointing to that variable that is stored in the pointer of a struct. Okay, I hope that makes some sense, besides being a little tricky. So let's create here another point, and we apply I don't know, some negative values here, like minus, let's say minus 3, and p3 dot y equals 2. Okay, so let's call it absolute value of p3, and yeah, so we call both for x. So oops, we have to call this function first. So remember, it doesn't take any arguments, so we can just invoke it like this, absolute value. And then we just pass p3 by reference like this, and then we expect it to be modified, its value. So we expect minus 3 to have become 3. Okay, so y, and then p3 dot x, p3 and y. Okay, no compile warnings, and x as expected, we got 3 instead of minus 3 because we normalized its value, and then 2 because it was already positive. So yeah, no difference at all. So you can see basically the difference between the arguments of this function, the distance function, and the absolute value function. Here we are passing by value directly, so it creates a copy of the variables we are passing. In memory, it's not the same address in memory, and then it performs some mathematical operations and then returns a value to the function that we're dealing with. And we can also pass it by reference, so it would act direct on the address where it's pointed to, so it won't create any copies of the value you're working with. And for that we usually use void functions, but like you can have a function with no arguments whatsoever. So for example, we can create a function which says hello on the screen, like void hello and no argument. And what it does, it's really simple. So it just prints hello on the screen, and that's it. So let's call it right away. Here, hello, like this. It's pretty simple. And then we compile, run, and then here we go, hello. And the thing is, with functions, you can you avoid code replicating code. Like, for example, instead of writing over and over again printf hello, you just call it like this. So, or instead use a for loop, which is much more convenient. And then yeah, it's really handy for especially if you're working with bigger programs. It's mandatory to break it down to functions, to small units of your program, so it gets more easily maintainable. Okay, so basically we have functions which return a type, which you have to declare at the same time you're returning. Functions that don't return any type at all, which we call void functions. Functions that take no arguments whatsoever. Functions that take values by reference, passing its pointer. And then functions that takes parameters by value, so it will create a copy of these parameters and then perform whatever it is that is performing. And here where we don't take copies in memory, so it would act direct on the variable that the pointer in this case, that you are passing through your function. Okay, so regarding functions, this is the basics. Okay, so that will help you writing more efficient software. And I hope you guys like this lecture, this video. Don't forget to like, subscribe, and comment. See you next time, and bye.